Great afternoon, morning, evening, mini mathematicians. So happy you could be here today. I'm going to give you 2 minutes to write down our lesson purpose. 6.1g, sums and differences of radicals, and this is on your Desmo. So pause the video for 2 minutes and please write down your lesson purpose. Awesome, let's get on to our Desmos lesson. So please log on to your Desmos lesson. And I want you to work on slide 1, 2, and 3 with your group. Pause the video for 2 minutes to allow students to finish slides 1, 2, and 3. Let's see how you did. Taking a look, is Joy correct? Joy is incorrect. This student said Joy is incorrect. To add terms, the values must be like terms with the same variables and exponents. Here, x and y are not like terms, and the expression 3x plus 2y is completely simplified. If I wanted to combine these two like terms, if they were like terms, if I had 3x plus 2x, we would have 5x. Let's go on to slide 2. Taking a look at slide 2, is Laura correct? No, Laura is incorrect. The terms here are like terms and can be combined. However, we only add the numbers on the outside. When we add these radicals, this is 4x plus 3x equals 7x. 4 root 5s and another 3 root 5s will give you a total of 7 root 5s. Hence, this expression would simplify to 7 root 5. Always make sure that the expression inside the radical is completely simplified. So let's look at number 3. The correct answer is 6 radical 2. Remember to use SQRT for your square root. 2 radical 2's and another 4 radical 2's are 6 radical 2. Always remember to check if this expression is simplified on the inside of the radical. Awesome. I'd like you to continue working through slide 8 with your group. Should take you about 4 minutes. Please pause the video now and continue working through slide 8. Awesome, let's take a look at these answers. Slide 4, answer on slide 4, 4 radical 6. Please be checking your answers as we go. Answer on slide 5, 3 radical 2. Make sure that if you need to see any of the work, you check the attached work on the Google Classroom. Slide 6, 3 radical 15 minus 2 radical 3. Notice these are not like terms. I cannot simplify any farther. Slide 7, 10 radical 2. Remember, we can rewrite all of these radicals to have the same number under the radical, which is root 2. Be careful if we're adding or subtracting the numbers on the outside. And slide 8 ends up being 10 radical 5 plus 10 radical 6. Again, because we don't have the same number under the radical or radicand, we cannot simplify this expression any further. Let's take a look at how we can apply the distributive property to simplify the square root of 2 being multiplied to the sum of 5 plus the square root of 8. So if I want to simplify this, we are going to multiply 5 times the square root of 2 and add that to the square root of 2 times the square root of 8. Then we're always going to simplify square root of 2 times square root of 8 completely. Always remember to check to see if we have the same number under the radical, which are like terms, to see if we can continue to simplify. Okay, now let's simplify on slide 10. Work with your groups and show all your work in your notebook. Pause the video for 2 minutes for students to finish slide 10 and 11. Students, please finish slide 10 and 11. Okay, slide 10. We should have ended up with 5 radical 2 plus 4. Don't forget that the square root of 16, that's 4. Okay, moving on to 11. Are these expressions equal? The correct answer is no. The two expressions are not equal. The exponent means the sum of square root of x plus square root of 2 is being multiplied by itself. You are squaring a sum. The final answer ends up being x plus 4 radical x plus 4. You can use an area model to find the final product. However, it's not going to be required. Just realize that these are not equal to each other. Awesome. Now we're going to be looking at slides 12 through 16, talking about rationalizing our denominator. So these are steps to rationalize the denominator. If you have a radical expression, a square root, a cube root, an nth root, in your denominator of a fraction, your expression is not simplified. It's like having a negative exponent. So taking a look, some examples of expressions that are not simplified are 4 over 7 radical 12, negative radical 17 over radical 11, 4 radical 3 over radical 7. So here's the steps to rationalize any denominator. The first thing you're going to do is you're going to multiply the numerator and denominator by the radical expression. This is just a fancy one. Remember, you're not changing the value of the fraction. So we're going to multiply 4 radical 3 over radical 7 by radical 7 over radical 7. This way, radical 7 times radical 7 will end up with radical 7 squared, and square roots and squaring are inverse operations, and we'll just end up with 7. Remember to always multiply numbers on the inside of the radical by numbers on the inside of the radical, and multiply numbers on the outside of the radical only by the numbers on the outside of the radical. So here, 7 and 3 are inside the radical, so that's radical 7 times 3. I don't touch the 4 on the outside. 4 square root of 21 all over 7. Always check to see if you can simplify numbers that are on the inside of the radical with perfect square factors, and check to see if the numbers on the outside can be simplified if they have any factors that are greater than 1. So taking a look, let's move on to slide 13. Slide 13 is 5 over square root of 2. That means this is not simplified because we need to rationalize our denominator. The number in the denominator is irrational. We cannot have irrational denominators. So I'm going to multiply numerator and denominator by the square root of 2, just a fancy one, which gets me 5 square root of 2 all over the square root. Well, 2 times 2 is 4. What is the square root of 4? Well, that's 2. And my numerator is 5 square root 2. 5 and 2 can't be simplified anymore, and neither can the square root of 2, which means the answer to slide 13 is 5 radical 2 all over 2. Awesome. Let's look at 14 together. Slide 14 has 8 radical 3 all over radical 6. This is not rational. We need to rationalize our denominator. Our denominator has a square root of a non-perfect square. So I'm going to multiply our numerator and denominator by the square root of 6. When I do that, I get 8 times, and you can say that this is 6 times 3, or just leave them as factors so we can continue to decompose them into perfect square factors. And here I end up with the square root of 6 being squared. Let's keep going. This ends up being 8 times 3 times. How can I break up 6 into factors? Well, that's 3 times 2 is 6. And this is all being divided by the square root of 6 being squared is just 6. From here, I notice I really want to simplify 8 and 6. They're both on the outside of the radical, and they both have a common factor of 2. So when I divide 8 by 2, I get 4, and when I divide 6 by 2, I get 3. Also, on the inside of my radical, I have this 3 times 3. So I can think about this ratio as 4 times the square root of 3 squared times the square root of 2 all over 3. Well, from here, I know that the square root of 3 squared is just 3. So I have 4 times 3 times radical 2 all over 3. Notice these cancel out. If you didn't notice it there, maybe you noticed that 12 over 3 square root 2, 3 goes into 12 4 times, so our final answer is 4 times the square root of 2. Okay, why don't you try slides 15 and 16 on your own with your group. Pause the video for 3 minutes while students continue working on slides 15, 16, and beyond. Thank you. Okay, the first thing I want to do on slide 15 is notice that I want to get rid of my square root of 10 in the denominator, which means I'm going to multiply numerator and denominator by square root 10. Numbers on the inside only get multiplied by numbers on the inside, and numbers on the outside only get multiplied by numbers on the outside. So here I end up with 4 square root of 7 times 10. You could simplify here, but I'm going to leave them as the factors since I'm going to break them up into factors to see if I can pull out any squares. Over 3 times, well, 10 times 10 is 100, or you can just write it as 10 squared, so you can see that the square root and the square will cancel out. So now, taking a look at my ratio, I end up with 4 square root of 7 times 5 times 2. These are all prime numbers, and none of them are pairs, so I know I will not be able to simplify radical 70. Over, this ends up being 3 times 10. If I continue working on this, I have 4 times the square root of 70 all over 30. Well, I know 4 and 30 are both even, so 2 goes into them. 2 goes into 4 twice and into 30 15 times, making my final answer 2 square root of 70 all over 15. Perfect. Let's move on and see how you did on 16. Taking a look at 16, I see that I need to get rid of the irrational number of the square root of 15 in my in my denominator, which means I need to multiply my numerator and my denominator by the square root of 15. Doing this, I end up with 12, and then I have 21 times 15 inside my square root over 7, and here I have the square root of 15 being squared. Excellent. Taking a look, I'm going to decompose or break down 21 into factors and 15 into factors in hopes that I have 2 of the same factors or pairs that I can pull out of my square root. I'm going to do this way because I don't have a calculator to deal with really big numbers. So let's see, I have 12 and 21, 7 times 3. Oh, that's great, because 15 is 3 times 5. All over 7 times, and the square root of 15 being squared is 15. Excellent. Let's see. Well, now I have 12. Inside my square root, I have 3 squared, I have 7, and I have a 5. And this is all over 7 times 15 is 105. 7 groups of 10 and 7 groups of 5. So taking a look here, I can pull out my 3, and I'll have 12 times 3. Left on the inside, I have 35, and all of this is over 105. I know that 12 times 3 is 36 over 105, and the square root of 35 is still in my numerator. 36 and 105 are both divisible by 3 because 6 plus 3 is 9, and 3 goes into 9, and 1 plus 5 is 6, and 3 also goes into 6. So how many times does 3 go into 36? 3 goes into 36 12 times. How many times does 3 go into 105? 35 times. So my final answer for number 16 is 12 square root of 35 all over 35. And this is in simplest form because the number under the radical does not have any perfect square factors, and 12 and 35 don't have any common factors except for 1. Great job. Excellent. I want to give you 8 minutes to work on slides 17 through 22. So please pause the video for 8 minutes and work on 17 through 22 with your group, and then we'll go over the solutions. Remember, if you'd like to see work for the remaining slides, make sure to check my posted work on Google Classroom. Thank you for pausing the video. Let's go over our answers. Slide 17 should be 3 radical 2 all minus 6. Slide 18. 7 plus 7 square root 5. 19. 2 radical 3 plus 3 all over 3. You may need to use parentheses to make sure this looks like one fraction. 20. 2 radical 7 minus 84. 21. 13 radical 3 minus 6 radical 2. And 22. Negative 2 radical 2. Remember, don't forget to rationalize your denominator. Awesome. Have a break while we change to video 2 to finish our lesson.